Hi everyone, I am JULKA. Today in differential equation part 3, we'll talk about linear order equation. Whenever we have dy by dx plus py equals to q, where p and q are constants or function of x. First we find integration factor. Integration factor is e raised to the power integration of p dx. And then we find equation. Equation is y multiplied by integration factor. Then integration of q into integration factor respect to x plus c. We can understand with the help of an example. Solve dy by dx plus y equals to e raised to the power 2x. Here p is 1 and q is e raised to the power 2x. So first we find integration factor, which is e raised to the power integration of p dx. P is 1, so the answer is e raised to the power x. Now equation is y into integration factor equals to integration of q into integration factor respect to x plus c. Integration factor is e raised to power x and the q is e raised to power 2x, and after solving we'll get y into e raised to power x equals to e to power 3x upon 3 plus c, and by further simplification we'll get y equals to e raised to power 2x upon 3 plus c into e raised to power minus x. Next example. Solve the differential equation dy by dx plus y equals to sin x. Here p is 1 and the q is sin x. Now the integration factor. Integration factor is e raised to power p dx, where p is 1, so answer is e raised to power x. Now the equation is y into integration factor equals to integration of q into integration factor respect to x plus c. Integration factor is e raised to power x and the q is sin x. Now first we separately solve sin x into e raised to power x respect to x. We take quotient equal to y, first function as it is, integration second, minus derivative first is cos x, integration second. And again when we integrate the second part, we'll get cos x as it is e raised to power x minus derivative first is minus sin x into integration of x, e to the power x is e to the power x. After further simplification, the quotient repeat. So sin x into e raised to power x is I. So when we solve this, we'll get I equals to sin x minus cos x into e raised to power x upon 2. Now put in first and we'll get y into e to the power x equals to sin x minus cos x into e raised to power x upon 2 plus c. And by further simplification, we'll get y equal to sin x minus cos x divided by 2 plus c into e raised to the power minus x. Next example, solve the differential equation x log x dy by dx plus y equals to 2 by x into log x. First divided by x log x both sides, and we will get dy by dx plus 1 upon x log x y equals to 2 by x square. Here p is 1 upon x log x and the q is 2 by x square. First we calculate integration factor, which is e raised to the power integration of p respect to x, and we will get e raised to the power log x. E raised to the power log y is y, so it is log x. Now equation is y into integration factor equals to integration of q into integration factor respect to x plus c. Integration factor is log x and the q is 2 by x square. Now when we solve 2 by x square log x, we'll use by parts, and after using by parts we'll get the answer y log x equals to minus 2 by x into log x minus 2 by x plus c. One more example. Solve the differential equation x dy by dx plus 2y equals to x square log x. First divided by x both sides, and we will get dy by dx plus 2 by x y equals to x log x. Here p is 2 by x and the q is x log x. First we calculate integration factor, which is e raised to the power integration of p respect to x. E raised to the power 2 by x dx is equals to e raised to the power 2 log x, which equals to e raised to the power log x square, and e raised to the power log y is y, so answer is x square. Now the equation is y into integration factor equals to integration of q into integration factor respect to x plus c. Integration factor is x square, q is x log x. Now when we solve the right hand side using by parts, we'll take log x as first function and x cube as second function, and we'll get first function as it is, integration second minus derivative of first into integration second, and now again integration of the second part. And after further simplification, we will get x to the power 4 log x upon 4 minus x to the power 4 upon 16 plus c. Now divide by x square both sides, we will get y equal to x square log x upon 4 minus x square by 16 plus c by x square. Now if linear ordered equation given like this, dx upon dy plus px equal to q, where p and q are constants or function of y, then we calculate equation using formula x multiplied by integration factor equals to integration of q into integration factor respect to y plus c, where integration factor is e raised to the power integration of p respect to y. Now we can understand with the help of an example. We have a question y dx plus x minus y square multiplied by dy equal to 0. Here dy by dx equals to y divided by y square minus x. So if we reverse this, if we have dx by dy equals to y square minus x upon y. So dx by dy plus 1 by y x equals to y. Here p is 1 by y and q is y. Integration factor is e raised to power p respect to y, which is e raised to power log y, which equals to y. Now the equation x into integration factor equals to integration of q into integration factor respect to y plus c. Integration factor is y and the q is again y. When we put and solve, we'll get answer x equals to y square by 3 plus c by y.